Hello everybody, my name is M.R. Muhammad Asharif. Today is April 5th, 2024. I'm going to talk about this Monte Carlo, what is Monte Carlo simulation for you. Monte Carlo simulation and first definition and how it works and a simple example. But generally it's much more diff- difficult, but I am going to talk it in a very simple. First of all, Monte Carlo simulation is kind of simulation that uses the uniform random number. However, some definition is that they don't use the uniform. Uniform is just uniform random number between, for instance, 0 and 1, and uniform distribution. It's about distribution, it's about probability and distribution, random number distribution is uniform. So first of all, uniform. Then it Monte Carlo simulation is going to solve a certain stochastic or deterministic problem. It can both solve stochastic or deterministic problem. Doesn't matter. This I will tell you now later. Also, it's not dynamic, so time does not matter. The progress of time, it's not uh, involved in the Monte Carlo simulation. So Monte Carlo simulations are static, not dynamic, and uses random number. Okay. First of all, how it generates. Monte Carlo simulation uh, originated during the World War II to apply it to problems related to development of the atomic bomb. It's the name, a sacred name was Monte Carlo because to apply to the problem related to atomic bomb. So it originated in 1940 something. Okay, and how it's very simple. Okay, and one example I just may make it clear by one example. For instance, of course, to solve integral, definite integral is not so difficult. You can use many other approach to solve the integral. I mean the area under the function gx. For instance, I is integral of a to b gx dx. This is the area under the gx. But we can use the Monte Carlo simulation to solve this problem, this simple problem. This is just simple application. In this case, let's take a y, a random variable between a and b, and this is so b minus a gx. So y is b minus a gx, where x is the continuous random variable. It can be both continuous or discrete, but first continuous, just continuous variable between a to b. So x is something like this. You find an x here between a xi, for instance, between a and b. The value of x is between this and this, and then the distribution is fxx, which is uniform. Then b minus a, 1 over b minus a is the constant distribution between over the b and a. So the area is 1 because b minus a multiplied by b minus 1 by b minus a is 1. So this is the distribution function of x. That's how we use this. First we define a continuous variable and then define this for solving this problem. We define a y which is b minus a, the integration limits a and b, then gx find from the value of the uniform random variable xi. So define the xi, find the gxi, and then multiply by b minus a, which is the value of y, which is yi, for instance. Wait, I will explain more. For instance, in this integral is gx, this is gx, this is gx, for instance, is the function gx of x between a and b. We would like to find this area under this. Of course, this is the integral. Yeah, anybody knows, between a and b of gx dx. So we approach this problem by just a limit of finding the small rectangular here and approach to infinite to find it. This is a general form of the integral. Expected value of y, which is y hat a or n, is the summation of each y. Y is the value of gx multiplied by b minus a. This is y. This is yi. So for each x under this point, for each random variable xi, we can find the value of gxi here and find b minus a, and this is for 1. Just maybe we can calculate many of this value for 1, 2, 3, 4, 5, 6 to infinite value of number, which is n, I 1 to n, between a and b. So it is average of summation of this over n. When you take the average, ensemble average of n, summation over n is the average of this yi. The average of this yi is the way to how to solve this integral. The expected value, which is average, is this. The xi is the number of the variable random number with uniform distribution. Y hat the estimation of the, then y hat the estimation of the area of the rectangle with the base b minus a and height b minus I over b minus a. But from this equation, if you, I return again here, I return here again, the value of this is between b minus a here. So the y hat is the area with the b minus a, I over b minus a. And the estimation of this, which is the value of integral, is the area. Actually, we want this area, which is this integral. And it is approved. I mean, it is proof that this y hat, this estimation, is unbiased estimator of I. Unbiased means not approaching to any value, definite value. With the variance, this is the probability theorem, variance of y hat n or n over n. If n approach to infinite, variance goes smaller and smaller. So that's why if n increases, then the value of the simulation, Monte Carlo simulation, approach to real value of the integral, that it is this. Therefore, large value of y hat, limit of y hat is I. One very different example I will show you here, and that's all. For instance, we want to solve a very simple equation, mean integral 0 to pi psi x dx. Everybody can solve this integral by just calculus, and it is number, then value will become 2. It's okay. But if how about the very difficult integral or unsolvable with ill value and so on, or different problem? This is just simple example. So we find like this. for each n, for instance 10 times, 20 times, or 40 times, and 80 is 160. How many points you take for the x? For instance 10 times, 20, and 40, 100. Gradually we defined for each number, we find the x, for instance 10x here, and find the gx here, find the gx for that x, and calculate this, and if it is n, it is 10 divided by that, and make the average like this, and gradually find the integral. For instance, if the function is pi sine xi, for each xi obtained from the uniform number, random variable, and then find pi sine xi, and divided by n, and then this is the estimation of that integral for that n, for instance 10. Summation is 1 to n, 1 to 10, for instance. If it is 1 to 10, or 1 to 20, or 1 to 160, and so on, you can increase this. You can make a simulation program with Python or MATLAB, whatever, to solve this. So xi is a random variable in radian. Put this, calculate the sine xi, and multiply by pi, and then find the mean value, the average of pi multiplied by this from 1 to n divided by r. This is the integral. For n equal, in the table, n equal 10, the value of y hat is 2.13. For n 20, the value is 1.951. For 160 is approaching to 1.993. Gradually it approached to something like this. If n approach to infinite, the value approach to the value of I from somewhere here approach to the real value, which is 2. This is the without integration and without anything, just using the Monte Carlo simulation. By increasing the number of n, you can, just by simple calculation of the gxi and the summation and so on, taking average, you can find the value of integral. If it is solvable integral, it's okay, but if it is unsolvable with e value, then it is much more efficient, this method of Monte Carlo simulation. As I told you before, it's not only for integration, it can use for any other purposes. That it is for more further application, you can refer to the many reference book and paper. Okay, here I am closing here my session, and thank you very much for your patience and listening. You can find my other video in my YouTube channel, and please give me some comment. Thank you very much. Bye.